For this lesson, we're going to be continuing to look at the families of quadratic functions. So if you remember from grade 10, a quadratic can be expressed in three different algebraic forms. First, we have standard form, which is y equals ax squared plus bx plus c. One important thing to notice about this is that our c here is always our y-intercept. That's always very important to know because if I'm given a quadratic in this form, I can immediately plot the y-intercept, or if I'm given the y-intercept, I immediately know the c value. Next, we have factored form, which is y equals a, x minus r, x minus s. And our r and our s are going to represent our zeros. But one major thing to remember is that in the equation, the signs are switched. And how we can remember this is if I were solving for my zeros, I would set each bracket equal to 0 and solve, and using my opposite operations would switch the sign. But if you're just making the equation, we're going to switch the sign. Finally, we have our vertex form, which is y equals a x minus h squared plus k. Now this looks kind of like our transformations that we've been working on, but the letters are a little different, so we're going to quickly go over what they do. So our a value is the same a value that we have in all forms. The h is going to be the x coordinate of our vertex. And again, it has our sign switched, right? And we can remember this because this also represents our horizontal translation. And if in the equation it's positive, we're moving the opposite way. So we always need to remember to switch our signs for things that have to do with our x. And this k over here is the y coordinate of our vertex. And we don't need to switch the sign for that or anything. But knowing that really helps us because if we have the vertex, we can just sub it right in. So the other thing that we're going to talk about that's new is a family of functions. And it's basically a collection of functions that share common characteristics. So I can determine the equation of one specific quadratic function by using the following steps. If I'm given the x-intercepts or zeros, I'm looking at going into factored form. And once I sub in my zeros for r and s, don't forget to switch the signs, then I can sub in another point to find a. If I'm given the vertex, it's in my best interest to use vertex form. And again, I sub in my vertex for h and k. Remember that we have to switch the sign on our h, and then I can use another point to find that a value. So I think the best way to go about this is to do a few examples. So let's get started. So example 1, determine the equation of the quadratic function that passes through the following point, 120, and has the roots -4 and 3 over 2. So because we're given the roots, we know that we're going to want to start with our factored form. This way, we actually have something to sub in. So because we're given that -4 and 3 over 2 are our roots, that means that we can fill them in here. And remember, we switched the sign. So it was -4 in the equation. It goes in as +4. And over here, it was 3 over 2, but it goes in as -3 over 2. Now, remember that our roots are 3 over 2. So I can write it this way. That's option 1. And that would have been the grade 10 way to do it. But in grade 11, when we're looking for our roots, this bracket would have given us this root. 2x minus 3 equals 0. 2x equals 3. X equals 3 over 2. So we can write x minus 3 over 2, or we can use this bracket to make our math a little bit easier. So I'm going to do it this way, but I want to show you the other way so that you can remember it from grade 10 as well. Okay, so now we need to find our A value. And if I start rearranging things to find A right now, I have way too many variables going on. So now I go back to my question to see if there's anything I haven't used yet. And I notice that I haven't used this coordinate, 120. And I can take this coordinate, x and y, and just sub it into my equation to solve for A. So I'm going to use the one on the right just because it's the grade 11 way to do it and I don't want to have to deal with the fractions. If you're more comfortable just subbing in the root and dealing with the fraction, you can absolutely do it that way too. So instead of writing a y, I'm going to write 20. Instead of writing an x, I'm just going to write 1. Now let's simplify the brackets. And for the second one, we have 2 times 1 is 2, minus 3 is negative 1, like this. That will give us 20 equals negative 5a. And to get a all by itself, we'll divide by negative 5 on both sides, and we'll get that negative 4 equals a. And finally, we want to take that a and put it into our equation. So if y equals negative 4, x plus 4, 2x minus 3. And remember, if you want to have that fraction running through, you absolutely could have. You would have ended up with the exact same answer, and it would have been valid as well. Okay, let's do a second example. So determine the equation of the parabola with the vertex at 1, 6 and passes through the point 0, negative 7. So because we're given the vertex, that's telling us that we should use our vertex form like this. And the first thing we'll do is we'll sub in our vertex. So remember that h is the x of my vertex with the sign swapped, like that. And then k is the y of my vertex, plus 6. Now again, I need to find a. If I start trying to isolate for a right now, I'm going to find that I have way too many variables to get a number value for a. So I look at my question and I see if there's anything I haven't used yet. And I haven't used that coordinate that we're given. So let's sub in that for x and y. So my y is negative 7, x is 0, plus 6. Now we start with the brackets. Next our exponents. And negative 1 squared is just 1, so we have a plus 6. And now to get a all by itself, we have to move that 6 over. So we'll get negative 13 equals a. And now that we have an a, let's fill in the whole equation. So we'll have y equals negative 13, x minus 1, all squared, plus 6. And that would be our final equation. Now let's try something that's a little trickier. So for example 3, we're going to determine the equation of the parabola in standard form, so that's important to highlight, that passes through the point 5, 6, and has roots of plus or minus negative 3. So because we're told it has roots, we know that we're looking at our factored form. Like this. So my roots are plus or minus 3. So let's start by filling in the roots. We still don't know what a is. So I've subbed in my roots. And now I need to find a. So if I look, what haven't I used yet? I haven't used this coordinate. So let's sub that in for x and y. So we'll have 6 equals a, 5 plus root 3, 6 minus root, 5 minus root 3, like this. And now what we're going to do is we're going to use our distributive property to simplify those brackets to find a. So because of the root 3's, we can't just combine them like we were before. There's no more like terms inside the brackets. So let's try multiplying it out and seeing if that makes things a little simpler. So we have 6 equals 5 multiplied by 5 is going to give me 25. 5 multiplied by negative root 3 will be negative 5 root 3. Then we'll have plus 5 root 3. And then we'll have minus 3. So remember that root 3 multiplied by root 3 is just 3. Now, if we collect some like terms, we have that 25 minus 3 will give us 22. And then negative 5 root 3 plus 5 root 3 is 0, so it goes away. And then we can divide by 22. So we'll get 6 over 22 equals A, which is the same as 3 over 11. And it's not a nice number, but that's okay. So let's fill that into our equation. And that's our final answer. Now, the last piece is that we need to put in standard form. So how do I get in standard form? I just multiply it out. So we're going to use our distributive property again, like this. So we'll have y equals 3 over 11 multiplied by x squared minus x root 3 plus x root 3 minus 3, and we'll get 3 over 11 multiplied by x squared minus 3, like this. And finally, let's just multiply in our 3 over 11. And it's not going to be nice numbers, but that's okay. Sorry, I'm running out of room here. We'll have y equals 3 over 11 x squared minus 9 over 11. And now we finally have our final answer. All right, let's do one more example together. So for example 4, we're going to determine the equation of the parabola in standard form that passes through the point 4, 7 and has roots of 2 root 5 and 2 minus root 5. Sorry, 2 plus root 5 and 2 minus root 5. So again, because it's giving us the roots, we're going to start with factored form. So let's write that out. Now, let's sub in our points. So we have y equals a x minus 2 plus root 5, x minus 2 minus root 5, like this. And the reason I wrote it like this is so that I remember to change the signs properly here and distribute this in nicely so we don't miss anything or make any mistakes. So if y equals a x minus 2 minus root 5, x minus 2 plus root 5, like this. And again, we're just changing the signs, but that's actually why we change the signs. So it does sometimes help just to see it, and that way we don't make any extra mistakes. Okay, so now we need to solve for a. So I look in the question and see if there's anything I haven't used yet. So I haven't used that coordinate 4, 7, so let's sub that in for x and y. 7 equals a 4 minus 2 minus root 5, 4 minus 2 plus root 5. Now just to make our lives a little bit easier, in the brackets, let's collect some like terms just to make our lives a little bit easier. And now, because we just can't collect all the like terms in the brackets because we're out of like terms, we're going to have to use the distributive property again. So let's multiply everything out, see how that goes, to ideally get rid of these radicals we have. So 7 equals a multiplied by 4 plus 2 root 5 minus 2 root 5 minus 5. Now if I collect like terms there, I will have -1, and then 2 root 5 minus 2 root 5 is just 0. Then I divide both sides by -1, and I will get -7 equals a. So let's fill that a value into our equation. So now we'll have -7, oops, we will have y equals -7 x minus 2 minus root 5 and x minus 2 plus root 5. Now the last thing is that we were asked to do this in standard form, so we're going to have to multiply this out just to make sure that we have it as simple as possible. So I'm just going to start by multiplying this x by everything, and we're going to have to do that for the whole thing. Now with the -2, sorry, this is getting a little bit messy. I'll try to do it one at a time so you can see what I'm doing. I'm kind of running out of room. Sorry about that. Our last one here will be minus root 5. There we go. And now let's collect some like terms in there. And our x root 5 and our negative x root 5, those two will cancel. And then we have 4 minus 5, which is -1. And our -2 root 5 and our +2 root 5 cancel. So we're left with this. Now let's multiply in that -7. So it looks really complex for a moment, but it does simplify itself out. And that is our final answer. So the hardest part of this question is definitely multiplying out that really long thing, but just take it slow and you can absolutely get there. So that is our last example.